Hello, virtual audience. I'm very pleased to be part of Bodo's Wide Bandgap event 2022. My name is David Sheridan, and I'm in charge of silicon carbide products at Alpha and Omega Semiconductor. I'm excited to talk to you today about our 650 volt and 750 volt alpha silicon carbide MOSFETs for industrial and automotive applications. A quick overview of Alpha and Omega Semiconductor if you're not familiar with us. We're headquartered in Sunnyvale, California, and are purely focused on power semiconductors and have a growing power IC product platform. We're showing excellent growth and currently the leading 5th MOSFET supplier worldwide. We have everything from low voltage and medium voltage MOSFETs, IGBT, super junction MOSFETs to IPMs and power IC products. And these come in a wide variety of packages from our own internal assembly and fabrication facilities. Alpha and Omega has several manufacturing locations, including an 8-inch fab in Oregon, USA, and a 12-inch joint venture fab and assembly locations in Chongqing, China. AOS also has several international R&D locations, as well as sales offices in each major region. 650 volt silicon carbide MOSFETs are finding a variety of uses and applications in industrial and automotive systems that I'm sure you're seeing in these presentations. These include solar, server telecom, and of course automotive, such as the onboard charger and the main inverter. Here on this diagram we show maybe an example of an onboard charger schematic, where on the left you have the input totem pole PFC, where silicon carbide can be used in the fast switching legs, and even silicon superjunction can also be used in the slow switching line frequency legs. And this is really enabled by the fast switching speed and low QRR of the silicon carbide MOSFETs compared to silicon superjunction MOSFETs or an IGBT with an FRD. Then on the DC-DC converter side, whether it's a CLLC or a CLLC or a DAB, whatever the topology, the use of silicon carbide, again with its fast and key excellent body diode characteristics, enable the high frequency and high efficiencies that these applications require. AOS has released a new line of silicon carbide MOSFETs for these applications we've been discussing. We've separated these into a 650 volt line for industrial use and a 750 volt line for automotive applications. Let's look at this table and review some key parameters of the new AOS MOSFETs. Comparing 60 milliohm devices across different competitors, we first see that the AOS MOSFETs have a typical threshold voltage of around 2.5 volts. They have an optimized low RDS-on versus temperature coefficient that gives an additional significant benefit over superjunction devices. A very low internal gate resistance for extremely fast switching. Optimized capacitances for shoot-through integrity. And of course, the key component of very low QRR to give the absolute lowest losses in demanding bridge applications. The Alpha Silicon Carbide 750 volt platform has a low RDS-on available down to 15 milliohms, and due to the advanced design and small die size, excellent switching behavior. Comparing with some similar RDS-on silicon carbide MOSFETs, we see that in the same system, these alpha silicon carbide MOSFETs can have almost 2 times lower losses when comparing the turn-on and turn-off energies as seen below. As mentioned, in bridge configurations like the totem pole PFC, automotive inverter, or ZVS topologies, one of the main benefits of silicon carbide is in the fast body diode and low QRR. On the right, you can see graphically the huge advantage of the alpha silicon carbide MOSFET, the pink QRR waveform, when compared to state-of-the-art superjunction MOSFETs. And compared with other silicon carbide MOSFETs, the alpha silicon carbide AOS MOSFETs show very competitive measured QRR values. But one of the most important and difficult design parameters for silicon carbide MOSFETs is the short circuit withstand time. For silicon carbide MOSFETs, the smaller die size and higher saturation currents in many designs leads to a rapid rise in temperature during the short circuit event, resulting in a quick failure time. In planar designs, one method to increase the short circuit withstand time is to increase the channel length. But this results in a much higher on resistance, increasing the die size and ultimately the die cost. Even trench MOSFET manufacturers often recommend a lower VGS drive voltage when needing strong short circuit capabilities, and this also significantly increases the on resistance. Measurements of multiple 1200 volt silicon carbide MOSFETs are shown in the figure on the right. Even though the AOS 1200 volt silicon carbide MOSFETs show the longest short circuit withstand time of the planar MOSFETs, close to the trench competitor, it is still not to the 5 microseconds plus designer's request. To break that trade-off, we developed this new 750 volt silicon carbide MOSFET platform that shows you can have a small, economical die size and a long short circuit withstand time. The 750 volt MOSFETs have a very low specific on resistance of around 2 milliohms centimeters squared, and shown below is the measured short circuit withstand time of greater than 9 microseconds at a 400 volt bus. Several available silicon carbide MOSFETs with both 650 volt and 750 volt ratings were measured in the same test system for consistency and accuracy. The results show the new AOS silicon carbide MOSFETs can have up to 4 times longer short circuit withstand time than the leading competitors. Of course, excellent specifications are not impressive without solid reliability. Poor gate oxides and threshold voltage drift under static or dynamic stresses can reduce the application efficiency during the product lifetime or even cause field failures. The graph on the lower left shows the threshold voltage measurements during qualification of the 750 volt MOSFET platform. Negligible drift was seen during the 1,000-hour test at 20% above the recommended VGS values. And in the lower right figure, it is shown that the measured gate lifetime is not sacrificed compared to the AOS 1200 volt MOSFET platform and has a lifetime well beyond application requirements. And as with the 1200 volt AOS silicon carbide MOSFETs, these 750 volt devices are fully automotive AEC-Q 101 qualified at 175C and PPAP capable. And finally, a look at our current portfolio of discrete silicon carbide MOSFETs available now and coming in 2023. For 1200 volts, we have MOSFETs with an RDS(on) down to 20 milliohms and up to 500 milliohms in a variety of standard packages, while the new 650 volt and 750 volt platform has the initial product released at 15 milliohms and 60 milliohms, expanding to a wider range of RDS(ons) throughout the next year. Just to note, most of these devices are also available in both industrial and automotive grades. I hope you enjoyed the presentation. If there are any questions, please join the live discussion sessions, visit the AOS website, or send us an email at one of the addresses below. Thank you very much.